Hello everyone, my name is Robert. I'm an Australian and I teach English. I also teach mathematics and physics. I've been in Asia since 2004. My first job was in Korea, South Korea, Seoul, and I taught young students from about 3 years old to about 13 years old. It was very, very noisy, very hectic, but very exciting, and I learned a lot about teaching young children as well as trying to appreciate the challenges they have at learning English language as well as the culture. After that, I had a good opportunity to go to China to teach mathematics and physics because that's my main area of study. And I went to Guangdong province, and for about 2 years I taught physics and mathematics to senior high school students who wanted to go overseas once they completed the course. Some of them did quite well. One went to Canada to study dentistry, for example. After that, I returned to Sydney for a year in Australia, and when I came back, I went to Shaanxi in northern China, the capital city, Taiyuan, and I taught at number 5 middle school, and I taught AP, Advanced Placement Calculus, which is my favourite subject, and physics. And I really like physics, but calculus is what I really enjoy teaching. From there, I went down to Wuxi, and I taught a year English, mathematics, and again physics. And then I went to Zhengzhou, and I did similar subjects there till the end of last year. My teaching philosophy is, because I like science, I like scientific method, I like to use what they call conceptual change theory. It's a bit of an old theory. It's based on the idea that students are like scientists. They need to be active and they need to explore what they're learning. And there's 4 main issues in conceptual change theory that I like to use on the students. The first one is that they're dissatisfied with their level of knowledge. So in physics or mathematics, you try to give them a problem that they have trouble solving or they may not be able to solve. And then you introduce, hopefully, a new method that they get an insight that they can do it better, faster, more understandable, and so they appreciate the lesson that I'm giving them. The second thing, it should be understandable. If you teach students something and they don't understand it, then I don't think they're going to remember it. So they should try to understand what they're doing. And the third thing, it should be plausible. They should believe that what you're telling them is true. I can give an example. I often like to teach, say, primary school, grade 5 or 6. The idea when you're teaching them fractions that 0.99999, repeater forever, is equal to 1. And I always get at least 2 or 3 students that challenge me and think this is wrong. And I think this is good because I like students to challenge me and question what I'm teaching them. And when they do that, I think the class is more enjoyable for them and they tend to remember things better. Okay? So, and the fourth thing is that it should be fruitful. It should be useful. If you're teaching students things and they don't think they can use it in their life, in their everyday life, then they're going to have trouble trying to remember it or learn it. Calculus is a good point. I think calculus is everywhere. If you drive a car, if you cross the street, you have to look at rates of change, the velocity of things, the speed of things. How can I cross the road before the car will hit you? In China, this is a challenge because it's very unexpected, some of the things they do on the road. Relating what I teach to them to the real world, I think is important. My background is applied mathematics, and I've done engineering as well as physics, and I really like to use theory in the real world, and I like to apply it to everything. I hope this gives you an idea of my background, and I wish everyone the best of luck. Thank you.